Hey everybody, I just wanted to take a little bit of time to go over the pre-lab for experiment 11. That way we can get started right away. Now I will tell you that this lab is a little tricky, and so I would highly recommend that you A, pay attention to the whole video, B, pause, rewind things that you didn't understand, and C, take notes. Maybe that should be the most important thing. Take notes on the parts that are confusing, because this is really the only help that I am going to give you for this lab. Keep in mind that for this lab, I want this lab to be considered more of a lab practical, even though that it's the middle lab, it's lab 11. I want this lab to be considered a lab where you are showing me how well you can do the chemistry without me intervening or me having to answer any questions. So keep that in mind, that this is really the only time. I will entertain questions before we begin the lab to see if there's any confusions, but once you get started, you guys are in it yourselves. So let's talk about this. First of all, for this lab, you're going to have to look up a procedure on how to make methyl benzoate, okay, using these reagents and catalysts, and making sure that you produce this many grams of methyl benzoate, assuming that you're going to have an 80% yield. Okay, so just real quick, if you're going to do that, let's see, so you want an 80% yield. So what was it, 21.4 grams. You're going to convert that to moles, right? I just want to double check that that's right. 21.8 grams. Okay. 21.8 grams. You're going to convert this to moles. You're going to add 20%, because you're only making, this is only 80%, so you're going to add 20% to get that up to 100, and then you can get how many moles of starting material or reactants, and then you can get grams if it's the benzoic acid, or you can get the milliliters if it's the methanol. And notice it says use a 518% excess, okay, of methanol. So once you have how many milliliters of methanol, you can then add plus 518%, okay. So that's kind of the pre-lab stuff. So you're going to look up the reaction. Now, fortunately, when you're looking up the reaction is actually pretty easy. I will tell you that this is something called a Fischer esterification. I'm sorry, I'm thinking of the guidance counselor in my school. It's Fischer esterification. Okay, so Fischer esterification is what this is. Now the problem isn't going to be that this is a super niche-y reaction where you can only find one or two. The problem is going to be that you are going to have hundreds and thousands of different versions of this same reaction, different temperatures, different methods of making it, things like that. So just make sure that you pick one that kind of matches what the lab is asking for in terms of the apparatus and the reaction and how long it's going to react for. So make sure that it kind of fits those criteria, and I'm sure that it'll be fine. Now, in my experience, excuse me, whoa, in my experience, I have found that this procedure isn't horribly long. It's only going to be, 3, 4, 5, 6 sentences, where you're going to talk about how much of each of the reactants that you're going to deal with. You're going to talk about what specific sizes of the containers you're going to use, and kind of this. I mean, so it's not a whole hog, do it all on your own sort of thing. There are a lot of hints here to get you to the right answer and the right version of the procedure, kind of whatever it is, modified based on what we have here. So just know that when you go and find that procedure, it should be, it doesn't have to be pages and pages of procedure. It's just going to be probably a paragraph or so. Okay. And not only do you not have to spend years looking for a procedure, this here is the purification method that you are going to use. Okay. Now, the funny thing is that this purification method is slightly different than what you have used in the past. Not horribly different, but is slightly different, and it really tests your ability to A, follow directions, and kind of B, understand the chemistry that is going on. So I want to make sure, and this is kind of where the questions always lie for this, and this is where I would kind of pick up making sure that you understand this by replaying the video, not fast forwarding, rewinding, taking notes, writing questions, that sort of thing, because this is slightly different but makes sense once we get into it. So let's talk about the purification. Okay, so when you purify this guy, okay, when you purify the methyl benzoate, the methyl benzoate is going to be a liquid, okay? But benzoic acid is a solid. So what you are going to do for this lab is you are going to make sure you isolate the liquid product, but you're also going to recover the solid benzoic acid. Okay. Which is a slightly different, because typically what we would do previous to this lab is just take this junk and just throw it away and not care, and all we would worry about is the liquid in the lab. We would only worry about the product. But there's a couple of reasons why we practice recovering the solids in the lab, okay, or recovering the unreacted starting material. Okay, for you, or for real life, maybe benzoic acid is really, really expensive and we don't want to waste any. Okay, that's kind of like in the real world. Like when I was doing reactions in my graduate school career, I was doing cancer drug research, and some of the starting materials that we had were hundreds of dollars per gram. Okay, and so we would want to make sure that if we had any extra, we would recover it and reuse it. Or even not a money thing, maybe it's a time thing. Maybe this thing took weeks to make, and we want to make sure that we recover it because we don't want to have to spend weeks making more in case our reaction goes bad or we don't, we use the wrong reaction conditions. So that's the real world thing. The other thing, the other reason why we do this for you that makes a little more sense is because of yield. Okay, what's going to happen is we're going to recover this guy. Okay, and we are going to, I will explain this, but we're going to subtract that from our yield so that we are getting a true sense of what our percent yield is going to be for the reaction. Okay, so that's kind of what's really going on here. So let me address where the confusion happens in this and why and where we get the keeping the solid and keeping the layer that contains the solid and keeping the layer that contains the liquid. Okay, and so if I were doing this, would write in your lab book, just like I'm going to try to do. The past couple of times I haven't been able to write on these documents, but I'm going to see what I can do. Okay, see how it says retaining both layers here? Oh, good, it's working. Okay, so what you're going to do is you're going to go through and you're going to do the ether layer, and you're going to have a water layer. Okay, so when you separate the ether layer and the water layer, you're going to want to kind of have contain two beakers, okay, one with ether and one with water. Okay. And then notice it says proceed with the purification of both the aqueous and ether layers. Okay, so this ether layer is where your product is going to be. Okay, your product is going to be. And so you want to do the ether layer, and you want to do this with the ether layer. Okay, and that is going to give you your product. Okay, now where it becomes unclear, and I'll change colors here, is that this is for this water layer. See, it says the aqueous layer is acidified, causing the precipitation of solid benzoic acid. Okay, so let me explain the chemistry of this, of what's going on here, starting up here. Okay, and so based on the chemistry that's going on there, let me scroll down and explain what's going on. Notice you'll have two separations to do, okay? And I know this is going to sound so weird, but I'm going to use a flow sheet to do this, okay? So you're going to have, okay, you're going to do one separation, sep funnel, okay, bad sep funnel drawing, okay? But out of that, you're going to get the water layer into one H2O, and then you're going to get the ether layer, ET2O. You're going to get the ether layer into another. Okay, so what I have done here, let me make sure that we follow along. Okay, is that here it says you're going to do the reaction mixture, a couple 100 milliliters of water and extracted with 50 milliliters of ether, retaining the ether layer. Okay, and then you may want to use some more ether to rinse the reaction out of the flask. Okay, and so now what this does, okay, is in this water layer is now water soluble stuff, maybe some acid like the sulfuric acid, H2SO4, any sort of organic salts. Now in this layer here, and I'll do it in a different color, in this ether layer now is your methyl benzoate. Okay. There, but also your benzoic acid. The benzoic acid is likely going to be dissolved in the ether layer rather than the water layer. There may be a little bit of benzoic acid here, but not a lot. Okay, so that first separation here, there's not going to be a ton of benzoic acid. But now look at what happens. Further separation of organic components is accomplished by taking that ether layer and using an aqueous solution of base, and that's where we're retaining both layers. Okay, so here you're taking this ether layer. Okay, like I said, it's funny that I'm using a flow chart, kind of a flow sheet to do this, but you're going to take this ether layer. Okay, and this will be my blue one. So this ether layer, and you're going to add base sodium carbonate. I'm moving around, so if my voice gets all crazy, then that's fine. Here, okay. Okay, so you're going to add base. So what that does is that takes the benzoic acid. Let me write benzoic. Methyl benzoate, nothing's going to happen to at this point. So it's going to take the benzoic acid, and it's going to remove this proton and turn it into sodium benzoate. What happens to what is sodium benzoate? Sodium benzoate is more soluble in water than it is in ether. Okay, so when we do that, okay, so now we're going to have our second separation. Okay, so now again, the water layer is going to come out the bottom, and now the ether layer is going to come out the top, and so this is your ether layer. Okay, and this is your water layer, and so now in here will be primarily your methyl benzoate, because nothing's really happened to it. And now in here, and I'll do this in a different color and I'll do that in green. Now in here will be your water soluble sodium benzoate. Okay, so now we have separated the sodium benzoate from the methyl benzoate. Okay, and that's what we want to do, and so now that is where we want to save both layers. And I'm moving again, so that's why my voice is acting weird. Okay, so that's where both layers get saved. Okay, because here, this is your product layer. Okay, this is your product layer. That's going to give you're going to isolate that. But now here, this guy, this is your recover that. Okay, now we can logically figure out what to do here. Okay, this we're just going to go on and is kind of what I would call kind of a standard purification. Okay, again, if we look at the thing here, it says wash the ether layer a couple of times, right? With sodium chloride solution. Again, that's just going to make sure that you get all the salts here, right? The ether solution not only contains low boiling solvents, some water, and the ester, right? Add magnesium sulfate. We add the magnesium sulfate to get rid of any of the water that's left over. The ether solution, we gravity filter through the fluted filter paper, which we did in experiment 9, and then the ether is removed by vacuum evaporation. So that's going to be done by rotovap. We're going to rotovap it. Okay, now I will help you set up the rotovap if you forget how to do it, but I'm not going to do any of my usual, like, are you sure this is the right layer? I'm just going to help you set it up, and that's it. Okay. And then we can then do this after it has dried for a week, right? But now let's talk about this, okay? And before we talk about this, let's go back to this. Notice that this is the sodium salt of the acid, okay? So that's the base of the acid, it's the conjugate base of the acid, okay? Well, how do we recover the acid? Well, we're going to have to turn that base back into an acid. So look at what happens here because of that. Okay, the aqueous layer is acidified. Well, once it's acidified here, we get that. We get that. What am I doing? Yeah, that's just horrible. Okay, we get this. Okay, Na plus O minus plus acid H plus, that's going to give us this. It's going to give us our benzoic acid back, and that's what you're going to see, and that's what it tries to describe here, is that the the precipitation of benzoic acid is going to happen. It's just going to kind of, you're going to see a white solid up here. Now, it's possible, hopefully not, well, hopefully yes, but it's possible that you get no precipitation. Okay, it kind of depends on how much water you use. Benzoic acid is slightly soluble in water, so I think it's soluble in something like 3 grams per liter. So just keep that in mind. So, you know, you're going to use the concentrated sulfuric or hydrochloric acid to regenerate the benzoic acid, and you're going to see it precipitate out of the solution. Then, how do you always isolate a solid? Well, eventually you're going to filter it using a Buchner funnel, right? Isn't that what we always do? Okay, so now we come back to this, and it says, look, much frothing occurs because you're adding an acid to a base. And then it says collect the benzoic acid by vacuum filtration, and then you're going to let that dry for a week, and you're going to weigh it, okay? And then look at what it says here. This is the key. This is why we're doing this. Is because if this is really kind of modeling real world stuff, and I'm going to grade you, if part of your grade is going to be based on % yield, look, we're going to take how much benzoic acid that was there, and then you're going to use that benzoic acid to calculate a new yield. Okay, so let me go over what that means. Okay, so, and this is like the twist. Okay, let me do a new page. Okay, so I'll do this 2 ways to show you why we're collecting the benzoic acid. Okay, I'll do it first. I'll do it in a kind of a like make-believe way, like a teaching by analogous way. That's not make-believe, an analogous way, and then I'll show you kind of an example of what really would happen. Okay, so provided that you can follow the directions, okay, you should get 2 things. So the theory behind this, here's the theory, the analogous way, right? And I'm making up numbers to make the math go, make the math seem easier, okay? So let's say we started with 10 grams, or that we started with 10 grams of benzoic acid, Okay. And based on that, we were going to make 10 grams of methyl benzoate. Okay, methyl benzoate. Okay. Now, what if in that reaction, what if we only made 5 grams of methyl benzoate? Okay, this was our theoretical yield. This was our actual yield. Okay, well, what is our percent? Our percent yield is 50%. We were supposed to make 10, we only made 5. Okay, that kind of makes a lot of sense. Well, now instead of saying, hey, we only made 10 grams of, we were supposed to make 10 grams of methyl benzoate, what if we paused this and we said, hey, you know what? We actually recovered 2.5 grams of benzoic acid from our stuff. So we recovered this from our material. Okay. So because we recovered 2.5 grams, and how many grams of methyl benzoate should we have made? Well, now we know that we should have only had 7.5 grams of methyl benzoate because we only had 7.5 grams of benzoic acid that we used here, right? This was 7.5 grams of benzoic acid because we know that all of it wasn't used in the reaction. We recovered 2.5 grams. So now, if we're only supposed to have 7.5 grams of methyl benzoate, and we had an actual yield of 5 grams, now our new percent yield is 67%. So which one is better, 50% or 67%? Well, duh, right, 67%. And it's not that you're fudging the numbers or massaging your grade in any way. Like, you're legit, that's a legit thing that you do because you know how much starting material you have left over at the beginning, and you know that that wasn't part of the reaction. So by doing this, it helps your yield calculation. And I shouldn't say that it helps it. What it does is it's giving you a more accurate representation of that, of your yield. And because one of the grades is a technique grade and is in part dependent on your yield percentage, this is going to then help your grade. But that's inconsequential, like it just is more accurate representation of the yield that you get. Okay, so in real life, so the real life example is, you're going to start with, let me make sure that I get this right here. Okay, so this is how much in theory you want to get. 21.8 grams of methyl benzoate, assuming an 80% yield. And that sometimes confuses people. So let me come up here. So 21.8%, grams, but you want to add 20% to that to get up to 100%. And so 20% of that is somewhere around, let's see, 10% is 2.18, so somewhere around 25 grams, okay? So you're expecting to get 25 grams of methyl benzoate. Okay, methyl benzoate. So let's go from there. Okay, so 25 grams of product. So you're going to start with about 23 grams of product of benzoic acid. Okay, probably maybe a little more. I'm estimating my numbers. Okay. Now, the lab is kind of telling you my standard is that the expectation is the best people are going to be able to get 80% out of this. Okay. So if you get more than 80%, you're probably doing really awesome, or you had a problem in the lab. Okay. So now we go through our purification, and we do the purification of the ether layer, the original ether layer. And when we do that, we find out that we have 12 grams of product. Okay. But that's not, so we don't do 12 grams over 25 grams. And that gives us, that gives us 48% yield. That's not what we're looking at. 48% yield. That's a big no. Okay. What we're going to do is we're going to add an extra step here by finding out how many grams of benzoic acid we recover. And so a typical recovery could be 2 grams of benzoic acid from isolating the water layer. Okay, so that means that because we had 2 grams of benzoic acid, that means that we really only reacted away 21 grams of benzoic acid. And 21 grams of benzoic acid, when we convert it to moles, okay, and it's a 1-to-1 ratio, really means that we only get 22.3. And again, I'm estimating and rounding numbers and stuff like that. Okay, go to moles. So moles of benzoic acid, moles of methyl benzoate. Okay, 20.3 grams of product here. Okay, and now our 12 grams of product that we got up here now becomes something better than a 50% yield. Okay, that becomes, let's see, 12, so that's somewhere around a 57% yield. Okay, and so that's the point of doing this recovery, and that's where people can get confused as to what's going on here. Okay, so when we come down here, okay, it's a long time to talk here, and it may help to even color coordinate this in here, right? So it says it's from here, further separate the ether layer. This ether layer is that ether layer here, and this aqueous layer here is this here. Okay, so just know that you do that. So it says turn in both ester and acid. Okay, so tell me how much ester and acid you're going to have. Turn it in. I'm actually going to want to see the product. You're going to hand it to me in a container. Okay, and you're going to determine the percent yield of the ether, of the ester, of the methyl benzoate, and you're going to tell me how much you recovered for the benzoic acid, and then you're going to figure out all the stuff about the product, the physical constants, the IR. You're not going to do NMR here, but you can you can do kind of whatever you think is the best way to know whether you have methyl benzoate or not. Okay. So that's the pre-lab for this experiment. Come to class ready to talk about or have specific questions about what you need to do so that we can answer those, and then I want to see what you can do. I've always had good results with this lab, and I think that this year is no different. And I think it helps you build your own confidence about the lab and being able to do that. And enabled to build your confidence in being able to do organic chemistry, because by the end of this you're going to do something that you've done before lots of times, making a product and isolating it, but something that you've done that's new, recovering some of the solid, and it says, hey, I can do that. So it's good stuff. Okay, so have a great time, and we will see you soon.